This video will go over composition of a trig function with its inverse. First, I want to encourage you not to rely on your calculator. If every time you need to find the sine, cosine, or tangent of an angle, you have to type it into your calculator, then you aren't really understanding the basic trig part of everything. So focus on knowing these next few pieces here. First, we have the quadrants of the Cartesian plane and their signs. So quadrant 1 is positive, positive, 2 is negative, positive, 3 is negative, negative, and 4 is positive, negative. Next, it's important to remember our families of angles and what their coordinates look like. So our pi over 3's, depending on the quadrant, the sign will change, but all angles that are pi over 3's are 1/2 and root 3 over 2. For pi over 4's, it's root 2 over 2 for both x and y. And for pi over 6, it's root 3 over 2 1/2. The way that I keep pi over 3 and pi over 6 separate in my brain is I remember that the 3's aren't right next to each other like this. Like this isn't pi over 3 starts with root 3. It's pi over 6 starts with root 3. And the 3 starts with 1/2. Next, all of this is on the unit circle. So here we can see our families of angles. I want you to notice that we can't ever simplify these radians. So pi over 3 is in the first quadrant, 2 pi over 3 in the second, then 4 pi over 3 and 5 pi over 3. Notice they'll never be able to be reduced. That's a way to help remember which is in which quadrant. Then we have our pi over 4's and our pi over 6's. I would not focus on trying to memorize the unit circle. I also wouldn't recommend having it next to you and referring to all of this all the time. It's important to be able to reason through it, which is what I'll model in the next problem. The last thing that is important and you do need to memorize is where the inverse trig functions are defined. Inverse cosine is defined in quadrant 1 and quadrant 2 only. And inverse sine and inverse tangent are defined in quadrants 1 and 4 only. Notice there's nothing defined in quadrant 3. I say there's a monster in there. So that means that we can't even travel into quadrant 3. So if we have an answer that's going to be in quadrant 4, we have to do a negative angle here. Let's look at a few examples. So for problems like this, where I have the inverse and then the sine, it's really tempting to just cancel those signs out. But that is not what we're going to do. First, we're going to deal with what's inside the parentheses. So here's my reason through it. 2 pi over 3 is in the second quadrant, where signs are negative, positive. The over 3's have the ordered pair 1/2 root 3 over 2. So 2 pi over 3 would be the negative 1/2 root 3 over 2. So the sign of 2 pi over 3 is root 3 over 2. Now we will replace the sign of 2 pi over 3 with our answer, the root 3 over 2. So our new problem is the inverse sine of root 3 over 2. That asks what angle has a y coordinate of root 3 over 2. Inverse sine is defined in quadrant 1 and 4. Since we're looking at a positive value, we must be in quadrant 1. Our family of over 3's has the y coordinate of root 3 over 2, and our pi over 3 in quadrant 1 is pi over 3. Let's look at another one. Here again, we start with what's inside the parentheses. This asks what angle has an x coordinate of negative 1/2. Inverse cosine is defined in quadrant 1 and quadrant 2, but since the 1/2 is negative, we must be in quadrant 2. My pi over 3's have the x coordinates of 1/2. and the pi over 3 in quadrant 2 is 2 pi over 3. Now I make the replacement, so the problem I'm solving is the cosine of 2 pi over 3. 2 pi over 3 has the ordered pair -1/2 positive root 3 over 2, so the cosine of 2 pi over 3 is -1/2. Now this problem uses arctan, so that is just another way of saying the inverse tangent. Here again we'll start with what's inside the parentheses. Negative pi over 6 has the ordered pair positive root 3 over 2, -1/2. And tangent is y over x, so the tangent of negative pi over 6 would be -1/2 over positive root 3 over 2. So we have a little work to do here. We can cancel out those denominators because they're the same. And then since we have the root 3 in the denominator, we probably want to go ahead and rationalize. And then we end up with negative root 3 over 3. So now we want to do our replacement. Our new problem is find the inverse tangent of negative root 3 over 3. If I kind of take the rationalization out, go back to over here, we're looking at the inverse tangent of -1 over root 3, which means what angle has a y over x of -1 over root 3. Inverse tangent is defined in quadrants 1 and 4. Since our value is negative, we must be in quadrant 4. The tangent of y over x, so that means our x must be root 3 over 2, which means we're looking at our family of over 6's. Our pi over 6 in quadrant 4 is negative pi over 6. Remember, for quadrant 4, we have to go negative. We can't go positive because we would go through the monster, right? Here, we start with what's in the middle. We look at our ordered pair for 7 pi over 4, and then we find its sign. Now we make the replacement, so our new problem is the inverse sine of root 2 over 2. This is asking what angle has a y coordinate of negative root 2 over 2. Inverse sine is defined in quadrants 1 and 4. Our value is negative, so we must be in quadrant 4. All of our pi over 4's have y coordinates of root 2 over 2, and our pi over 4 in quadrant 4 is negative pi over 4. Here we have the arc cosine. So again, that's just another way to say inverse. We'll start with what's inside the parentheses. We'll look at its ordered pair. If it's cosine, we're looking at the x value. Now we'll make our replacement, so our new problem is finding the inverse cosine of negative root 3 over 2. There's the question that we're asking in English. Inverse cosine. Sorry about that, I fixed that error. Inverse cosine is defined in quadrants 1 and quadrant 2, but since we're looking at a negative value, we're looking at quadrant 2. My family of over 6's have x coordinate of root 3 over 2, and my over 6 in quadrant 4 is negative. Well, that's not quadrant 4, hold on. There we go. My over 6 in quadrant 2, is 5 pi over 6. All right, you can do it. Good luck.